All right, this is EET112 Lab 3 Part A, where we're going to measure the time constant, or tau, of the 100 microfarad capacitor in series with the 47 kilo ohm resistor. Okay, so the first thing we want to do is set up the power supply for 10 volts DC. So right now you can see that it's currently set at 5 volts and it's not on, so I'm going to turn it up to 10. And I've got the current limit set to 0.1 amps. And so I'm going to turn it on and measure it directly with the DMM. And you can see that the DMM is measuring a little bit high. So I'm going to turn down the voltage so that this shows me exactly 10 volts. There. So here's an example of why you can't really trust the power supply reading, because it's not known to be accurate. So the DMM should be more accurate than the power supply. Okay, so I've got it set to 10 volts. Now I'm going to turn it off. And you'll notice that now the DMM is going to float down to some low voltage. It may not be exactly 0. It could be in the millivolt range, but don't worry about that. Now we're going to, you're going to assemble the circuit as shown in figure 7. And that switch you see in figure 7, that's not a physical switch on your breadboard. That'll be this on-off switch of your power supply. Okay. All right, so now I'm going to move the camera to focus on the oscilloscope, because that's what we're going to get to next. Bear with me while I maybe zoom in a little bit here. Hopefully that's good. Okay. So now the next step is I'm going to hook up the power supply to the circuit as you see in figure 7. So let me do that. Take it off the DMM and connect it to the circuit. Okay. All right. And now I've got channel 1 of the scope hooked up to measure the voltage across the capacitor. And I'm going to hit the default button on the scope just to make sure that you and I start at the same spot in terms of where the scope is programmed. So now we want to make sure that channel 1 is on DC coupling. So if you hit the 1 button, you'll see we have DC coupling, so that's good. We want the bandwidth limit to be 20 megahertz. Why? Because we know we're not going to see any signals over 20 megahertz. So this effectively would get rid of any noisy signals that the scope might pick up above 20 megahertz. We're going to put the scope probe on 10x. So 10x. And then select it. Now make sure that your probe, the little red switch on your probe, is also set to 10x. If it's not, then your scope readings aren't going to be, they're going to be off by a factor of 10. We're going to set the vertical scale to 2 volts per division. So 2 volts per division there. And the horizontal scale, we're going to go all the way up to 1 second per division. So this, we're going to have to go quite a ways here. 100 milliseconds, 500 milliseconds, 1 second. All right. Now we're going to press the roll button on the scope that is just under the horizontal zoom knob. So right here. Okay, so now what you see is the scope. We don't have to depend on the trigger now. It's just going to show you what's happening in real time. So every grid is 1 second of time. So you notice now it's it's flat and lined at ground. So now we want to adjust this so that we move this trace down to one grid above the bottom grid. So let me do that. Probably should have done that before I turned on the roll. So -6 volts, that tells you the fact that it's 0.06.00, you're right on the grid line. So this is this is ground now down here. All right. So that should look like figure 10, which it does. And now I'm going to turn on the power supply. So I turned it on, and you can see what's happening here. The cap is charging up. All right. So what we're going to do is we want to freeze that right about here. So if you take that black ground wire you see in the picture and just short it to ground, that's going to watch what happens on the scope here. See, now we're back. We've shorted the cap out. It's jiggling because I'm kind of jiggling it as I'm touching ground. I'm going to release it again. And then I'm going to hit this run stop button right when this gets over toward the edge here. And I do it about there. Okay, where you do it, it's not important. Just so you see the majority of the rising cap voltage. All right, so once you've got that, then you're going to use the Y cursor to measure VSS. Oh, we didn't do that. So I need to let this go. Sorry, let's let it go again. So that is our VSS. The cap, I gave it enough time. The cap's now fully charged. So now what we want to do is use the Y cursor to measure this voltage. Or I think if we just go to the measurement menu, you notice let's ask it for the maximum here. So you notice the maximum is right at 10 volts. So that's our VSS. All right, hit type to make that menu go away. All right, now I'm going to short the cap again with the black wire. First, yeah, it's running, so short the cap and then release it. And then again, I'm going to hit the run stop button when it gets over to the left. We just want to capture most of this here. So let's do it about here. Okay, so now what we want to do is turn on the cursors so that we can measure the tau. So the tau we want to measure, or the time we want to measure, is when does that trace get to 63.2% of VSS, because that's the definition of tau. Well, 63.2% of 10 is 6.32. So where does this rise up to 6.32 volts? How long does that take? All right, so let's turn on the cursors. And you notice I've got both X and Y are on. But the first thing I want to do is put X1 right at the start here. So let's move this to X1, select it, and then adjust it so that it's right where we start charging the cap. So I don't want to put my face in front of the camera here to block the screen, so that's about as good as I can do from the angle I'm at. Okay, so that's that. Now we want to set, let's set Y1 down there at the bottom. So Y1, select it, and move that down to what is essentially ground. Let's see, Y1, I'm going to try to put it right at 0. Okay, you see Y1 is at 0. And now I'm going to put Y2 at our 6.32 volts, because that's where we define tau. So select Y2, move Y2. You can see Y2 right here. I need to put it at 6.32. There's 6.32. And now all I need to do is move X2 over to where that intersects. So now I'm going to choose X2, select it, move it over there. All right. You might see my head in the camera, but I'm going to try to let you see a good view there. Well, that's about, maybe a little more, I don't know. It's about as good as I'm going to get. From your angle, you might be able to tell that I'm not quite on there. But so now what we're measuring, why doesn't X1? It seems like X1 should be showing up here more. Let's see. Yeah, for some reason X1, I must have moved it. I'm going to select it again. I need to move X1 right over here to where it starts rising. Okay. I don't know how that got moved. Maybe you could see what I did wrong, but X1 needs to be here. Y2 needs to be up here where you're at 6.32. And of course, Y1 is 0 because we're starting from ground. So now if you read here, delta X, that is our time constant tau. So what I'm reading there is for my case, 5.16 seconds. That's my tau. So that's your measured, that'll be your measured tau. So just, I want to check. So also by now you should have measured your 47K resistor and put that in the first table, but let's see here. So if I take my measured tau of 5.16 seconds and divide it by 47K, and you should divide by your measured 47K, but I didn't measure mine. So this is just to make sure I'm in the ballpark here. So if I do that, I come up with 109.8 microfarads for my cap. So that's pretty good. The cap should be within 10%, or excuse me, probably more like 20% of 100 microfarads, most caps tolerance. So that's pretty good. So that's the end of part A. And you should fill out all those numbers in that table in the first part of the lab. It's just a vertical column of numbers there. All right. End of part 8.